I'm Mr. Joseph, a chemistry teacher. I'm back with my lectures. So still on redox reaction. Today's lecture will be looking at redox reaction and balancing of simple ionic equation. So at the end of the lesson, students should be able to identify redox equation, apply the rules for balancing simple ionic equation, then balance the simple ionic equation. So please, I want you to listen attentively and get the best from today's lecture. Thank you very much. Now looking at redox equation, of which we've treated redox reaction. So let's dive deep into redox reaction. Now a redox reaction is an oxidation reduction reaction that involves transfers of electrons between two species. That means it has to do with what? Gain of electron and what? Loss of what? Electron. In a redox reaction, there's electron gain and what? Electron loss. That's what we call a redox reaction, where reduction and oxidation takes place at the same time. Now redox equations are generally written down in ionic form, except they're in a neutral molecular state or gaseous state. Now, redox equation could be simple or complex. So, we want to look at how we can balance redox reaction, redox equation. Now, balancing of redox equation involves several methods, depending on whether the reaction is in an acidic medium, an alkaline medium, or a neutral what? A neutral medium. Now, redox equation could be simple or complex. We have the simple ionic equation and complex ionic equation. So, we want to look at how we can balance the simple ionic equation or complex what? Ionic equation. So, that's what we'll be looking at generally, which is balancing of redox equation, which involves what? As the acidic medium, alkaline medium, or neutral medium. So we are going to start with what? The simple ionic equation. We can balance the simple ionic equation. Then we'll move over to balancing of what? Complex ionic equation, either in acidic medium or in alkaline medium or in the neutral medium. So it's as simple as what? ABC. So please, I want us to listen attentively and get the best. So we want to focus on balancing of ionic equation, simple ionic equation to be specific, how we can balance simple ionic equation. Now let's look at some of the rules, that is used in balancing of simple ionic equation. Now to balance the simple ionic equation, we use the half cell reaction method. So we want to look at the rules for balancing simple ionic equation. Please, we are going to follow the rule judiciously so that we can balance a chemical equation. We can balance an ionic equation. The first one is write down the oxidation number of each element or ion that is present. So you have to write down the oxidation number of each element or ion that is present. Then you divide the equation into two half cell equations. That is the oxidation half cell equation and the reduction half cell equation. That's what makes it a redox equation, a redox reaction. Then balance each half cell equation. Thus, balance the atoms first by adding appropriate coefficient to the atoms already present. So you balance the atoms first by adding appropriate coefficient to the atoms already present. Then secondly, balance the charges by adding the appropriate number of electrons. Then after balancing the atoms, first by adding appropriate coefficient to the atoms already present. Secondly, you balance the charges by adding the appropriate number of electrons. So you balance the charges by adding the appropriate number of electrons. Then you multiply each half cell by using the coefficient of electrons to balance electron gain or electron loss. So you have to multiply each half cell, the reduction half cell and the oxidation half cell, by using the coefficient of electrons to balance electron gain or electron loss. Then the next step, the final step, is add the two half cell equations to get the net equation, which is the balanced simple ionic equation. So you add the two half cell to get the net equation. That is the reduction half cell and the oxidation half cell. So which is the balanced simple ionic equation. So these are the steps, these are the rules that is used in balancing simple ionic equation. So you have to follow the rules step by step to balance what? A simple ionic equation. So having considered the rules for balancing of simple ionic equation, so we want to apply the rules in balancing of the example before us to balance the simple ionic equation. So this is a simple ionic equation. So we're going to apply the rules step by step to balance this simple ionic equation. The first step is to write the oxidation number of each element or ion that is present. So oxidation number of aluminum is 0 on the reactant, oxidation number of copper is +2, oxidation number of aluminum is +3, oxidation number of copper is 0. So we'll balance what? We'll have to write down the oxidation number of each of the element or ion that is present. Then the next step is to divide the equation into two half cell equation, which is the oxidation half cell equation and reduction half cell equation. From our previous lecture, we know that oxidation is the increase in oxidation number in terms of oxidation number, while reduction is the decrease in oxidation number. So where we have increase in oxidation number, that is oxidation. Where we have decrease in oxidation number, that is reduction. So from 0 to +3 is increase in oxidation number. So aluminium undergoes what? Oxidation. So this oxidation half cell. Then copper is from +2 to 0, which is decrease in oxidation number. So it undergoes reduction, so which is copper. So this reduction. So we divided the equation into two half cell, oxidation half cell equation and reduction half cell equation. So the next step is to balance the atoms on the oxidation half cell and balance the atoms on the reduction half cell. On the oxidation half cell, aluminum is 1 on the reactant, aluminum is 1 on the product. So the atoms are balanced on the oxidation half cell. On the reduction half cell, copper is 1. We have 1 atom of copper on the reactant, 1 atom of copper on the product. So the atoms are balanced on the reduction half cell. The next step is to balance the charges. So we have to balance the charges. So what happened is that on the oxidation half cell, here is 0, here is what, +3. So we have to balance the charge. So we'll add 3 electrons here to balance the charge. So 0 plus 3 minus 3 is 0. So on the oxidation half cell, the charge is balanced. Now let's go to the reduction half cell. Copper is what, +2 here, and copper is what, 0 here. So add 2 electrons here to balance the charge here. So +2 minus 2 is 0. So the charges are now balanced on both the reduction half cell on the what and on the oxidation half cell. So the next thing to do is to balance the electron gain and electron loss. The electron loss on the oxidation half cell is +3. Electron gain on the reduction half cell is +2. So we have to balance electron gain and electron loss. And to do that, we have to multiply the oxidation half cell and the reduction half cell by a coefficient to balance electron gain and electron loss. So we have to multiply this oxidation half cell by 2, and we have to multiply the reduction half cell by 3, so that electron gain and electron loss will balance out. So multiply through by 2. So we'll have what, 2 aluminum, 2 moles of aluminum to give you what, 2 moles of aluminum ion plus 6 moles of electron. This is the oxidation half cell. Then the reduction half cell, 3 moles of copper 2 ion plus 6 moles of electron to give you 3 moles of copper. So electron gain, electron loss balance. On the oxidation half cell, electron gain is balanced on the oxidation half cell, and on the reduction half cell, the electron gain, electron loss, they are all balanced. So we'll add the two half cell equations to get the net equation, to get the balanced ionic equation. So electron gain, electron loss will cancel out. So we'll add the reactant of the oxidation half cell to the reactant of reduction half cell, the product of the oxidation half cell to the product of the reduction half cell. So we'll now have 2 moles of aluminum plus 3 moles of copper 2 ion to give you 2 moles of aluminum ion plus what, 3 moles of copper. So as you can see, the equation is now balanced. So this is the balanced ionic equation. So it's as simple as ABC. All you need to do just to follow the rules step by step, and you balance the ionic equation. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So just feel free to reach out to me and attempt as many examples as possible. So I'm going to solve another one again. So please, I want you to pay attention. So this is example 2. This is another example, which is a simple ionic equation. We have to balance the simple ionic equation. So we'll follow the rules for balancing of simple ionic equation. The first step is to write down the oxidation number of each of the elements or ion that is present. Oxidation number of zinc is 0. Oxidation number of silver is +1. Oxidation number of zinc ion is +2. And oxidation number of silver is 0. And we all know that oxidation is the increase in oxidation number, while reduction is the decrease in oxidation number. So from 0 to +2, there's an increase in oxidation number. That means zinc undergoes oxidation. So we're dividing the equation to two half cell equation. So this is the oxidation half cell. Zinc undergoes oxidation, which is increase in oxidation number. Then the next step is what? From +1 to 0, which is decrease in oxidation number. So silver undergoes reduction by decrease in oxidation number from +1 to 0. So silver undergoes what? Reduction. Silver ion undergoes reduction to give you what? Silver, which is reduction. So we've divided the equation into two half-cell equation, oxidation half-cell equation, and reduction half-cell equation. The next step is to balance the atoms on the oxidation half cell and also on the reduction half cell. So we want to balance the atoms on the oxidation half cell, both on the reactant and on the product. So on the reactant, zinc is 1 year. On the product, zinc is 1 year for the oxidation half cell. So the atoms are balanced for the oxidation half cell. Now let's go to the reduction half cell. Silver is 1 year and silver is 1 on the product. Silver is 1 on the reactant. So the atoms are all balanced. Now the next step is to balance the charges. Now to balance the charge. So zinc on the reactant, on the oxidation half cell, zinc is 0 on the reactant and zinc is +2 on the product. So to balance the electron, so add 2 electrons here so that the charges will be balanced. So here 0 plus 2 minus 2 is 0. So on the oxidation half cell, the charges, they are all balanced. +2 minus 2 here is 0 and 0. So the charges are balanced. Then we'll now go to the reduction half cell. We have to balance the charges. On the reactant, the charge is +1 and the charge is 0. So we have to add an electron here so that the charge will be balanced. So +1 minus 1, 0 and 0. So the charges are balanced on both the reactant, on both the oxidation half cell and the reduction half cell. So the charges are all balanced, both on the reactant and on the product of the oxidation half cell and the reduction half cell. The next step is to what? Add to balance electron gain and electron loss by adding appropriate coefficient of what? Electrons. So we want to balance electron gain and electron loss. On the oxidation half cell, electron loss is +2, while electron gain here on the reduction half cell is +1. So to balance electron gain and electron loss, we want to balance electron gain and electron loss. So we multiply the reduction half cell by 2 coefficient of electron to balance electron gain and electron loss. So multiply here by 2. So we have 2 moles of silver ion plus 2 moles of electrons to give you 2 moles of silver. So electron gain on the reduction half cell is +2. Electron gain on the reduction half cell is +2. Electron loss on the reduction half cell is +2. So electron gain, electron loss is now balanced. So we have to add the two half cell equation to get the net equation, to get the balanced ionic equation. So this will electron gain, electron loss will cancel out. So add the reactant of the oxidation half cell to the reactant of the reduction half cell, the product of the oxidation half cell to the product of the reduction half cell. So it will now be what? Zinc plus 2 silver ion, 2 moles of silver ion, to give you zinc ion plus 2 moles of silver. So this is the balanced ionic equation. So the equation is balanced both on the equation is what? Balanced both on the oxidation half cell and the reduction half cell. So this is the balanced ionic equation, which is the net equation. So it's as simple as what? ABC. All you need to do is attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. So I want to take another example, balancing of simple ionic equation. So we're going to follow the rules as usual. So step by step, we're going to follow the rules. Now this is sodium. Sodium reacts with hydrogen ion to give you sodium ion and hydrogen gas. So this is simple ionic equation. So you have to balance this simple ionic equation. So you have to balance this simple ionic equation. So the first thing to do is to write down the oxidation number of each element or ion that is present. So we have to write down the oxidation number. Oxidation number of sodium here is 0. Hydrogen here is +1. Oxidation number of sodium is +1. Oxidation number of hydrogen here is 0. Then the next step is divide the equation to two half cell equation, oxidation and reduction half cell equation. From our previous lecture, oxidation, we are meant to understand that oxidation is increase in oxidation number, while reduction is the decrease in oxidation number. So we have to divide the equation into two half cells. So you can see that sodium increases from 0 to +1. That is oxidation, undergo oxidation. So this is the oxidation half cell, sodium, to give you sodium ion. So increase in oxidation number. So this is the oxidation half cell. Then you can see the hydrogen ion decreases from +1 to 0, which is the reduction. So you have the reduction half cell here. This is the reduction half cell. The next step is to balance the atoms on the oxidation half cell and the reduction half cell. So we have to balance the atoms. On the reactant, sodium is 1. On the product, sodium is 1. So the atoms are balanced on the oxidation half cell. Let's go to the reduction half cell. Hydrogen is 1. Here, hydrogen is 2. So we'll put 2 here. So on the reactant, for the reduction half cell, we have 2 atoms of hydrogen on the reactant, 2 atoms of hydrogen on the product. So the atoms are all balanced. The next step is to balance the charges. So what do? The charge is 0 and the charge is what? Plus 1. So what do we do to balance the charge? We add an electron here. So to be plus 1 minus 1, which is 0. So the charges on the oxidation half cell is balanced. Then let's go to the reduction half cell. We'll have the charges plus 2 and the charge is 0. So to balance the charge, we add 2 electrons here, which will now be equal to plus 2 minus 2 is equal to 0. So 0. The charges are all balanced on the reduction half cell, on the reactant, and also on the product. So the next step to do is to balance electron gain and electron loss by adding appropriate coefficient of electrons. So what do we do now? We multiply this by 2, multiply oxidation half cell by 2 to balance electron gain and electron loss. Electron gain here is plus 1. Electron loss here is 1. Electron gain here is plus 2. So we have to multiply to balance electron gain and electron loss. So it will be 2Na to give you what? 2N sodium ion, 2 moles of sodium ion, plus what? 2 moles of electrons. Then this one will be 2 moles of hydrogen ion plus 2 moles of electron to give you 1 mole of hydrogen gas. So electron loss and electron gains now balance. So the next step is to add the 2 half cell equation to get the net equation. You add the 2 half cell equation to get the net equation. So electron gain and electron loss will cancel out. So this is plus 2. So these 2 will cancel out. So we now have what? 2 sodium plus 2 moles of hydrogen ion. We'll add the reactant of the oxidation half cell to the reactant of the reduction half cell, and the product of the oxidation half cell to the product of the reduction half cell. 2 sodium ion plus hydrogen gas. So this is the balanced ionic equation, which is the net equation. This is as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please attempt as many questions as possible. Thank you very much. So I want to take another example, balancing of simple ionic equation. So we're going to follow the rules step by step as usual. So we have to balance this simple ionic equation. You have ion 2 and 2 react with bromine. Give you ion 3. Bromide ion. So this is simple ionic equation. So you're asked to balance this simple ionic equation. So following this rules step by step, the first step is to write down the oxidation number of each element or ion that is present. Oxidation number of ion here is plus 2. Oxidation number here is 0. Oxidation number here is plus 3. Oxidation number here is minus 1. So you've written down the oxidation number of each element or ion that is present. The next step is to divide the equation into 2 half cell equations, oxidation half cell equation and the reduction half cell equation. And we know that oxidation is the increase in oxidation number. So from plus 2 to plus 3, that is oxidation, which is increase in oxidation number. So we'll have ion 2, Fe2 plus to ion 3, Fe3 plus. So this is the oxidation half cell. Then reduction is the decrease in oxidation number. So from 0 to minus 1, that is reduction, which is decrease in oxidation number. So have Br2 bromine to give you the bromide ion, which is the reduction half cell. Then the next step is to balance the atoms and also balance the charges by adding appropriate number of electrons. So what happens is that we have to balance the atoms on the oxidation half cell. We have 1 atom of ion on the reactant and 1 atom of ion on the product. So the atoms balance on the oxidation half cell. Now let's go to the reduction half cell. We have 2 atoms of bromine on the reactant and 1 atom of bromine on the product. So we'll add 2 here. So the atoms on the reactant and the product for the reduction half cell, they are all balanced. So the atoms are balanced. Now the next step is to balance the charges by adding appropriate number of electrons. So the charge here is +2 and the charge here is +3. So we'll add an electron here to balance the charge. So +3 minus 1 is +2. So the charges are now balanced on the oxidation half cell, +2, +2. Now let's go to the reduction half cell. The charge here is 0 and the charge is what? -2. So to balance, we'll add 2 electrons here to balance the charges. So 0 minus 2, 0 minus 2, 0 minus 2. So the charge is what? -2, -2. So the charges are balanced on the reduction half cell and also on the oxidation half cell. The next step is to balance electron gain and electron loss. To balance electron gain and electron loss. So what we need to do is electron loss here is 1, electron gain here is 2. So to balance electron gain and electron loss, so that electron gain and electron loss will be the same, we'll multiply each of the half cell by appropriate number of electrons to balance electron gain and electron loss. So we'll have to multiply the oxidation half cell by 2 times and the reduction half cell by 1. So to balance electron gain and electron loss. So we can just leave it like that, or you multiply it by 1. So here you will have what? 2 moles of ion 2 to give you 2 moles of ion 3, 2 electron. Then here you have bromine, 1 mole of bromine plus 2 moles of electron to give you 2 moles of bromide ion. So this is the oxidation half cell and this is the reduction half cell. So to get the net equation, we have to add the oxidation half cell to the reduction half cell. Electron gain and electron loss and electron gain will cancel out. So the net equation now will now be, I think I have to erase the top so that I will have enough space. So let me erase this so that I'll have enough space to write down the net equation. So the net equation will now be, so the net equation will now be what? 2 Fe2 plus bromine. So we'll add the reactant of the oxidation half cell to the reactant of the reduction half cell. Then you have what? Product of the oxidation half cell to product of the reduction half cell. 2 moles of ion 3 plus what? 2 moles of bromide ion. So this is the balanced ionic equation. So it's as simple as what? ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So feel free to reach out to me in case you encounter any challenge or any difficulty. Mr. Joe, your chemistry teacher. Thank you very much. Subscribe to my YouTube channel, Joe Mystery. Like, share, comment, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe to my YouTube channel. Thank you very much.